हम स्टार्ट करते हैं। और जो अब हम स्टार्ट कर रहे हैं, पहला लेक्चर जो स्टार्ट कर रहे हैं, दैट इज़ अबाउट स्कैटरिंग थ्योरी। स्कैटरिंग थ्योरी आपने अपने मास्टर्स के लेवल पर यानी क्वांटम 2 के अंदर डिस्कस की होगी। स्कैटरिंग थ्योरी इनफैक्ट जो हिस्टोरिकल पर्सपेक्टिव है स्कैटरिंग थ्योरी का, दैट स्टार्टेड इन 1911। और 1911 से लेकर 1930 तक, जब बेसिकली रदरफोर्ड इनफैक्ट डिस्कवर्ड दी न्यूक्लियस। और उसने कैसे डिस्कवर किया था, दैट इज़ ही शॉट अ बीम ऑफ अल्फा पार्टिकल onto which is alpha particle जो हैं, they are basically doubly ionized helium atoms, जिसके अंदर से दोनों इलेक्ट्रॉन्स आर स्ट्रिप्ड अवे, and so they are alpha particles, and a beam of alpha particles were shot on a gold foil. So that is in fact a reaction between alpha particle and the atoms। और हम इस एक्सपेरिमेंट को अल्फा प्लस नाइट्रोजन 14 करें, तो देन वी वुड हैव इन द आउटपुट अ सर्टेन नंबर ऑफ पार्टिकल। और बेसिकली जो इसका जो स्कैटरिंग थ्योरी है या कोलिजन थ्योरी है एट दिस लेवल was in fact this was developed in 1911 to 1930। yeah, so जो इसका हिस्टोरिकल कॉन्सेप्ट है या हिस्टोरिकल पर्सपेक्टिव है, वो बेसिकली डिस्कवरी ऑफ न्यूक्लियस है बाय इनफैक्ट रदरफोर्ड। सो वी कैन राइट historically the scattering process that dates back to in fact 1911 to 1913। और आपको मालूम है 1913 के अंदर बोर थ्योरी या बोर मॉडल वाज डिस्कवर्ड, एंड दिस वाज बेसिकली द रदरफोर्ड discovery of atomic nuclei। So that was the starting point। यहाँ से हमारी इनफैक्ट स्कैटरिंग थ्योरी स्टार्ट हुई। और इस प्रोसेस के अंदर सॉर्ट ऑफ अ बीम ऑफ अल्फा पार्टिकल्स। और जब हम बीम ऑफ अल्फा पार्टिकल्स कहेंगे, सो अल्फा पार्टिकल्स का मतलब है डबली आयोनाइज्ड हीलियम एटम्स। डबली आयोनाइज्ड हीलियम atoms। So a beam of alpha particle is shot on a gold foil। So समथिंग कुछ इस तरह का इनफैक्ट, अगर हम इस सोचें कि किस तरह से इनफैक्ट एक्सपेरिमेंट हुआ था। सो वी हैव सम टारगेट, लेट्स से दिस इज द टारगेट, and then a beam of alpha particles, so it is some beam which has this profile and so on and so on। So इसका इसमें some of the particles which in the incoming particles, they are reflected back on the same line। Some of the particles, they are reflected at a certain angle, certain smaller angle, and then some of the particles, they are scattered at large angle until we have no more scattering। So this is the target foil, जिसको आप gold foil करें। This is the beam of alpha particles। So when the beam of alpha particles, they are coming towards the target, so some of the particles are reflected at 180 degrees, and that is retracing their original path, and some of the particles are then are reflected at a smaller angle and larger angle, and some are not reflected, and as you can see, it goes on like this, where we have some sort of an asymptotic phenomena। So they are not completely sort of unaffected by the presence of the target particle, but they have somewhat some indication of influence. एंड सो हम इस चीज़ को कहते हैं दैट इज़ एन एजम्प्टोटिक बिहेवियर. सो ये जो बिहेवियर आपको इस जगह पर नज़र आ रहा है एक्सट्रीम राइट साइड पर, इसको हम नाम देते हैं एजम्प्टोटिक सॉर्ट ऑफ बिहेवियर. और ये एजम्प्टोटिक बिहेवियर ही बुनियादी तौर पर हम डिस्कस करेंगे अपने जो हमारा डिस्कशन रहेगा. इससे पहले भी आपने स्कैटरिंग थ्योरी पढ़ी हुई है, लेकिन हम थोड़ा सा इसका प्रीव्यू देंगे स्कैटरिंग थ्योरी का, एंड देन एज वी मूव अलोंग हम इसको शिफ्ट करेंगे टू एन अंडरस्टैंडिंग जो आपके एडवांस लेवल तक चला जाएगा. ठीक है ना? सो दैट इज़ व्हाट वी इंटेंड टू डू हियर. So, बेसिकली इस इस एक्सपेरिमेंट से जो रदरफर्ड ने 1911 में परफॉर्म किया, उससे उसने क्या चीज़ हासिल की? द वन वेरी इंपॉर्टेंट इनफैक्ट क्वांटिटी ऑफ फिजिकल क्वांटिटी दैट ही कैलकुलेटेड वाज द स्कैटरिंग क्रॉस सेक्शन, और दी जिनको हम इनफैक्ट अपनी स्पेक्ट्रोस्कोपी के अंदर या क्वांटम मैकेनिक्स में भी कॉल इट एज probability amplitude. So you have to think that there are ways of investigating quantum systems. Whether those quantum systems are individual particles such as atoms and molecules, or whether they are congregation of atoms and molecules. So one way is spectroscopy, and in the other way is through collisions or scattering. In spectroscopy, scattering is a somewhat a destructive method, whereas spectroscopy is a non-destructive method where a beam of light is shown on some material, and then there are transition between bound states of that system, quantum system. Whereas in case of scattering, a beam of particle, जैसे for example in case of this Rutherford experiment with the discovery of nuclei, which he discovered in nuclei in 1911 and 13, a beam of some particles, that could be alpha particle or proton or electron or some other high energy particle, that is shot into some target material, and the scattered particles from the target material, they carry information about the target material, and that information वो हम बेसिकली हासिल करना चाहते हैं. तो हम अभी इसकी प्रॉपर डेफिनेशन देंगे एट एन एडवांस्ड लेवल ऑफ स्पेक्ट्रोस्कोपी, sorry, advanced level of scattering theory. But what he in fact discovered, what he in fact calculated, that he can calculate scattering cross sections, cross section, which is basically the probability amplitude. And then जो basically he was not doing spectroscopy, he was interested in finding the structure of matter, and what he concluded that all the mass of the inside the atom is basically concentrated in a very small region, and that's how he discovered the atomic nucleus. So what he concluded that all of the mass is concentrated inside the small region called nucleus. Yeah, so that was his understanding, and based on his understanding, there are certain discoveries or certain developments, such as the planetary model of atom, planetary model of atom that was in fact put forward by Bohr. So that is known as the Bohr theory. So और in fact in उसको आप Bohr model भी कहते हैं. So these are some of the development because of the earlier scattering experiment. So and in fact this Bohr model is in fact a good approximation of quantum mechanics, and a better approximation was then developed 10 years later in 1923 with the advent of modern quantum mechanics. So you could think about starting from 1900 to 1923 as quantum mechanics, which is old quantum mechanics, or modern mechanics, और मॉडर्न फिजिक्स जैसे कि इसको कहा जाता है. बट देन आफ्टर 1923 एंड लेटर जो क्वांटम मैकेनिक्स में प्रिसाइज डेवलपमेंट जो हुई, दैट लेड टू द फॉर्मेशन ऑफ मॉडर्न quantum theory. So Bohr model is a good approximation of quantum mechanics, and then later on a better approximation was developed 10 years later. So one could say that Bohr model is a good approximation. A good approximation क्यों कह रहे हैं? क्योंकि आपको याद होगा बोर मॉडल के अंदर we talk about circular orbits, we talk about stationary orbits, and also in quantum mechanics we talk about stationary orbits. But in quantum mechanics, which is after 1923, and then with the development of Schrödinger equation, आपको मालूम है कि then we then later on talked about not just circular orbit but elliptical orbits. That is, there is all shapes and sorts of orbits जैसे जिनके अंदर electrons would be residing, and then a formal mechanism was developed how to put electrons inside the atom, and that is in fact those orbital as s orbital or the p orbital and so on. So how the electrons are basically distributed in those orbital, that was dependent upon certain set of numbers or selection rules. An electron can be identified by four quantum numbers, crudely speaking: principal quantum number, orbital angular momentum quantum number. Then we have projection of the orbital angular momentum quantum number. Then we have a spin, intrinsic spin quantum number, and the projection of intrinsic spin on some preferred direction. So these are the some quantum numbers which were later on developed as a consequence of the solution of the time independent Schrödinger equation. Yeah. So जिसको आप लेगोरे पॉलिनोमियल को सॉल्व करते हुए लेगोरे सॉल्यूशंस निकालते हैं. सो बेसिकली हम ये कह सकते हैं कि बोर थ्योरी or Bohr model is a good approximation of quantum mechanics, and that was developed some 10 years later. 10 years later, that is in 1923 and onwards. Yeah, so that you could think about in this manner. सो बेसिकली इसका मकसद स्कैटरिंग थ्योरी का जो रदरफोर्ड ने स्टार्ट की थी 1911 के अंदर विद द डिस्कवरी ऑफ द एटॉमिक न्यूक्लियस, इसका मकसद सिर्फ यही नहीं था, बट ही वांटेड टू प्रोब द एटॉमिक न्यूक्लियस, ही वांटेड टू प्रोब द मैटर, एंड देन ऑब्वियसली इसी थ्योरी की मदद से जब लेटर डेवलपमेंट हुई और ऐसे ऐसे डिवाइसेस सच एज एक्सेलरेटर्स with which you can speed up those particles, or that is to increase their energy, you now able to probe the atomic nucleus as well. Or not only you can probe the atomic nucleus, but you can also probe the subatomic particles, or even particles. What is the structure of particles? For example, what is the structure of proton, and so on. So इट इज़ नॉट जस्ट कि आप यानी scattering theory is not just meant to study the stationary states of the system, but you can also study, in fact, particles, atomic nucleus, and so on. So that is uh, scattering theory can also be used to probe atomic nuclei, yeah, or it can be used to probe uh, particles or subnuclear particle, sub particles. So in fact, you can say that with the discovery of this new method, a whole range of new avenues can be started. And अब हम ये जानते हैं we can have LHC, Large Hadron Collider. So we have accelerators in which we can smash atoms together, or smashing atoms together. So there is a lowest level which you have done in your third year experimental lab, Frank-Hertz experiment, जहाँ पर आप बुनियादी तौर पर bound states of hydrogen atom निकालते हैं, yeah, using Frank-Hertz experiment. So this is one end, one very lowest end of set of experiment, and the other highest end of set of experiment could be some accelerator, maybe in Switzerland, Large Hadron, or in CERN, where you could, in fact, by increasing their energy, you can smash two beams of particles and see all sorts of phenomena. So we have to sort of differentiate different types of scattering. So we can say on one hand, we have Frank-Hertz experiment. Uh, this is basically the experiment which you have performed and in your third year course. और इस experiments की मदद से we can discuss the stationary states of an atom. Yeah. Then on the other hand, on the extreme end, other extreme, uh, you can think about extreme. We have accelerators. Accelerators in which we can smash smash atoms together. And when we smash atoms together, there could be collisions, which could be elastic collision, that is, there is no change in the identity of particles, colliding particles, or there could be, in fact, inelastic collisions where there is a change of identity of particles. Yeah, so or there could be uh, various effects जो हो सकते हैं उसके अंदर. ना सवाल ये एक थोड़ा सा, क्योंकि हम ये एक प्रिलिमिनरी डिस्कशन है, सो हम ये सॉर्ट ऑफ जानना चाहेंगे कि व्हाई वी डू इस, बिकॉज इट इज़ अ वेरी इंपॉर्टेंट topic in physics, that is the scattering theory or the collision theory. So why physicists want to study interactions between particles, sort of scattering theory. So उसकी मदद से आप या तो जैसे मैंने आपसे कहा स्टेशनरी स्टेट्स, और दूसरे इन जनरल व्हाट वी नीड टू डू इज़ टू टॉक अबाउट द इंटरेक्शंस बिटवीन पार्टिकल. और ये भी ख्याल रखिएगा हम लेटर ऑन आपके कोर्स के अंदर एक आर्टिकल है या एक टॉपिक है जिसको इंटरेक्शंस बिटवीन पार्टिकल्स। सो इवन दो स्पेक्ट्रोस्कोपी के अंदर हम बात करते हैं कि वी फायर अ फोटोन onto some atom or molecule and the atom and molecule absorbs that photon. But in fact, in general, अगर हम इस concept को discuss करें in some general sense, then we can say that this is also a two-body interaction where a photon is interacting with an atom and molecule in such a way that atom and molecule absorbs that photon and make certain transitions or make certain changes within its own self, that is changes in the bound state. So uh, स्कैटरिंग हम क्यों करते हैं? सो लेट्स आइडेंटिफाई सम ऑफ दोज points. So physicists physicists they want to study interactions between interactions particles। और ये ख्याल रखिएगा, ये सब चीज़ हम इसलिए करें, वी कैन डायरेक्टली स्टार्ट फ्रॉम स्कैटरिंग थ्योरी। आपने पार्शियल वेव एनालिसिस किया होगा। एक मेथड, दो मेथड हैं पार्शियल वेव एनालिसिस। जो लो स्कैटरिंग फिनोमेनन, दैट इज़ व्हेन द इंटरैक्टिंग पार्टिकल्स हैव लो एनर्जी, देन हम उसमें स्कैटरिंग प्रॉब्लम को सॉल्व करते हैं यूजिंग अ मेथड नोन एज पार्शियल वेव्स और पार्शियल वेव्स वेव एनालिसिस। Or agar say for example we have two particles or more than two particles and they have high energy, then in that case of high energy scattering, Born approximation या Born perturbation theory इस्तेमाल की जाती है in order to study the effects of those collision. So हम यहाँ पर ये इसलिए कर रहे हैं कि एक तो वो तरीक़ेकार थे जो हमने किए हैं अपने लोअर क्लास के अंदर। यहाँ पर हम प्योरली और इनफैक्ट मोर ब्रॉडर अंडरस्टैंडिंग डेवलप करेंगे स्कैटरिंग थ्योरी की, कि किस तरह से स्कैटरिंग थ्योरी होती है। और ये भी सोचना शुरू करें, आप सोचें कि beam of particles, they are coming from a large distance away from the target particle, having no influence of the target potential, and so they are free particles, yeah. And when they come close to the target material, they sense or they feel the potential of that target particle, and they scatter. And when they scatter, they carry the information about the target. And if you could sort of compare those two beams, that is the beam before collision and the beam after collision, then from that comparison you can get some information about the target particle. So this is the way we would like to study. So that's why मैं यहाँ पर स्कैटरिंग के लिए, कि हम स्कैटरिंग करते क्यों हैं, उससे मुतालिक कुछ बातें हम यहाँ पर डिस्कस करना चाहते हैं। दूसरी बात ये कि we want to study forces in one very simple in fact study जो हाइड्रोजन एटम के अंदर इलेक्ट्रोमैग्नेटिक फोर्स है। what is the nature of force between proton and electron in the hydrogen atom, that we already know, but there are certain other forces जो हमें नहीं मालूम, which are not well understood. So other is to we want to study forces, for example in hydrogen atom, in hydrogen atom uh, for example, EM force, electromagnetic force, yeah. That is the force between proton and electron. That is basically what we want to study. This force or such forces between electronic structure and the nuclear structure are somewhat well understood. Yeah. So these forces are somewhat, we would say somewhat. Why somewhat? Not, we do not know exactly, but somewhat in some sense we do know कि वो forces क्या हैं. Okay, somewhat well understood. Well understood. But some other forces they are not understood. For example, हम बात करेंगे forces by virtue of which quarks sort of combine to form protons. So one would say, but there are forces. There are forces we don't understand well. एंड इन फोर्सेस को स्टडी करने के लिए, इन इंटरेक्शंस को स्टडी करने के लिए वेल इनफ हम क्या करते हैं, वी यूज दिस स्कैटरिंग थ्योरी. Either the forces are not very well understood or basically it is very hard to understand them. Yeah, दोनों cases हो सकते हैं. Yeah, जैसे for example, it is very difficult to have a free quark, but still quarks are there inside a proton, and they combine with each other to form a proton or a neutron. So it is very hard to understand those interactions, or harder to understand uh, forces in some interactions, in certain type of interactions, rather, certain type of interactions. So there are situation where there is a potential which is affecting particles, or maybe some particles which are trapped by potential, and this is also the case in case of subatomic particles. So also there is, or there are, in fact, there are situations where where there are potentials affecting particles, or may be trapped, or may be trapped particles. So those particles are trapped inside some potential, trapped particles by the potential, by the presence of potentials. ठीक है. So and if we say that they are trapped, so this is basically, in fact, the holding of particles, holding of particle together. So जैसे कि हम प्रोटॉन और न्यूट्रॉन के केस में जानते हैं, दैट इज देयर आर ट्रैप पार्टिकल्स जिनको आप क्वार्क कह रहे हैं, and those quarks are trapped by a certain potential, and that is leading towards holding of those particles together, forming a particle known as a composite particle known as a proton or a neutron. Uh, and then in this case, in this particular case, we cannot measure the potential directly. There is no simple way. So the only way we could study is through scattering theory. So in such cases, there is no simple way of studying such potentials, that is, such potentials which are responsible for holding those particles. And so this requires scattering theory. Yeah, so you see so there are so many in fact ways जिसमें स्कैटरिंग थ्योरी इस्तेमाल कर सकते हैं. सो हम मैकेनिज्म को डिस्कस करेंगे. मैकेनिज्म को डिस्कस करने से मुराद हमारी ये है कि किस तरह से ये स्कैटरिंग प्रोसेस हो सकता है. सो one could send a beam of particles near some potential, and then we would like to see how those particles are affected by that potential or this central potential. So they would be reflected in different directions, and when they are reflected in different directions, so we would measure from those reflected particles, we measure the scattering cross sections, and that is in quantum mechanics we call it as probability amplitude. So what is basically the mechanism? So a beam of particles are sent to some some target system जिसको you want to investigate, and then we would see and the scattered particles are studied. So some in how we study, so some are scattered at large angles and some at small angles, and from this what we measure scattering cross sections, or scattering cross section को then basically you call it as the probability amplitudes in quantum mechanics. Probability amplitudes, that is the probability that a particle will be scattered from some scattering center. So बुनियादी तौर पर ये हमारा तरीक़ेकार होगा. अब इस तरीक़ेकार ही को हम इनफैक्ट सॉर्ट ऑफ रियलाइज करना चाहते हैं, और पहले हम थोड़ी सी बेसिक डेफिनेशंस देंगे, बेसिक आइडियाज़ देंगे, जिसमें हम बात करेंगे कि द स्कैटरिंग थ्योरी कैन बी डिस्कस इन द डोमेन ऑफ relativity theory. So there could be a relativistic scattering theory, there could be a non-relativistic one, scattering theory, there could be a theory in which we would be discussing time dependency, that is time dependent Schrodinger equation will be solved. There would be a theory, there is one domain where time independence, that is we do not consider time as or the system as evolving in time, so that is time independent Schrodinger equation. Then there is one other mm, uh, sort of characterization of scattering theory. There could be a single channel scattering theory, there could be a multi channel scattering theory. So ये सारी चीज़ें हम यहाँ पर डिस्कस करेंगे. So let's say अच्छा